Hi everyone, today we're going to put some of that factoring that we did the last couple of days to good use. We're going to learn how to actually solve quadratic equations and inequalities. Now this may be a little bit of review for you, so it's kind of good to go through it again just to make sure you know what you're doing. But before we do that, we want to talk a little bit about rational numbers. A rational number is a number that can be written as a fraction. So if you have the integer 2, 2 is a rational number because it could be written as 2 over 1, so it could be written as a fraction. 0.15 is a rational number because it's 15 hundredths. It can be written as 15 over 100 and also simplified. So it also is a rational number because it can be written as a fraction. Now if I have a fraction, let's say 6 over 0, put that in your calculator. Go 6 divided by 0 and see what you got. Some calculators may say error domain, undefined, because it can't be done. You can't have 0 in the denominator of a fraction because it's considered to be undefined. It can't be done. So 6 over 0 is not a rational number. So before we begin actually solving, we have to decide what makes a fraction or a rational expression undefined, because we never want to get an answer that would make that denominator equal to 0, because then really that answer wouldn't work because it would make it undefined. Well, in order to find what makes a rational expression undefined, we're going to set the denominators equal to 0 and solve for the variable. Well, why aren't we touching the numerators? Because the numerator really can be anything we want it to be. It's the denominator that can't be 0. Once it's 0, it's undefined. So in order to see for number 1 what would make that rational expression or that fraction undefined, we're going to take the denominator and set it equal to 0. Now we have a quadratic equation. And the way to solve a quadratic equation is we're going to actually factor in t-bar. Always try GCF first. In this case we can't, so we're going to factor. I hope everybody realizes this is dots. It's an a plus 3 and an a minus 3. We're going to t-bar, setting each factor equal to 0 and solving. So a plus 3 equals 0 and a minus 3 equals 0. So if I was to solve the left side, I'd subtract 3 on both sides. A is a negative 3. And if I was to solve the right side, I would add 3 to both sides, so a is a positive 3. So my answer here would be a equals plus or minus 3. Those are the only two integers that would make that denominator equal to 0, that would make that rational expression undefined. Okay, let's move on. So again, we're trying to look for what would make it undefined. So undefined means the denominator would have to be 0. So I'm only going to take the denominator of 4x times x squared plus 6x plus 8 and set it equal to 0. It looks like they already GC'd that for me, so I just have to go to two binomials. So I have 4x, set up my two binomials, and it's an x and an x. Factors of a positive 8 that'll give me a positive 6 plus 4 and plus 2. T-bar. In this case, when I T-bar, I'm going to have three answers. I have to set each factor equal to 0 and solve. Okay, on the left, the very first one, I would divide each side by 4 to get x by itself, and 0 divided by 4 is 0. The guy in the middle, I'd subtract 4 on both sides and get x as a negative 4. And the last one, I'd subtract 2 on both sides and get x as a negative 2. So all the values of x that would make that rational expression undefined would be x equals negative 2, 0, and a negative 4. Okay, so we worked with rational expressions and undefined. Let's move on. Now we're actually going to solve equations. Now, in order to solve equations, it's got to be in standard form where it's ax squared plus bx plus c equals 0. A, b, and c are integers, and the squaring variable has to come first. The variable with no squaring is in the middle, and the integer that comes on the end should not have a variable attached to it. All right, once it's in standard form, then you're ready to factor in t-bar. Please always remember to try GCF first, and then go to two binomials for factoring. Okay, let's take a look at number 3. Well, with number 3, it's in standard form as much as I'm going to get it. I don't have a c value, but I can't make one up. And it's already set equal to 0, so I'm going to solve it from there. I can GCF out an x and then get x minus 9. I no longer have a squaring, so I can't factor anymore. I'm ready to t-bar. I'm going to set each factor equal to 0 and solve. Well, the factor on the left solved itself. It's 0. On the right, I'm going to add 9 to both sides and get 9. Now I'm going to take my answers and check. It's very important that you check your answers. If I plug 0 back into the original, 0 squared is 0, minus 9 times 0 is 0, 0 minus 0 is 0, and it checks. And then I would do the same thing for the 9. Just to save a little time, I will tell you that both answers do check. So my answers to that equation for x, my values of x or my roots, are 0 and 9. Let's take a look at number 4. Well, in number 4, I can't solve it yet because it's not in standard form. I have to get it equal to 0. So I'm going to subtract 24x on both sides. I'm going to have 2x squared minus 24x plus 72 equals 0. I couldn't subtract 24x from anybody, and the reason I put it in the middle is so that it would be in standard form. Okay, it's set equal to 0, it's in standard form, I'm ready to factor. I'm going to GCF out of 2 and get x squared minus 12x plus 36 and then equals 0. I still have a squaring, so I'm going to factor even further, bring down the 2, and go to 2 binomials. And I'm going to get an x and an x, factors of a positive 36 that would add to give me a negative 12, minus, plus, whoops, what do I want to use here? Minus 6 and a minus 6, yes, I was correct. T-bar, setting each factor equal to 0, and solving. We'll take a look at the very first factor. I can't actually say 2 equals 0, so at this point, I'm going to cross that out. He's not part of my answer. The one in the middle, I'll add 6 to both sides and get x is 6. The one on the end, I'll do the same, add 6 to both sides and get x is 6. So in this case, I only have one answer, or one value of x, or only one root to that equation, and that would be x equals 6. Okay. Now we've solved a couple equations, we're going to learn how to solve inequalities. What do you have to do to solve inequalities? Well, there seems to be quite a few steps here. So if I was you, I'd pause the video, write down the steps, and then come back so that you can concentrate more on completing the problems. Okay, now that you have the steps written down, let's take a look and see how we're going to do this. With number 5, it's an inequality. So it says to rewrite the inequality as an equation. Okay, that's easy. So I have x squared minus 5x minus 6 equals 0. Put it in standard form, it already is, so I'm going to factor and solve for the roots. So basically I'm going to factor and t-bar, just like I did on the other examples. I can't GCF, so I'm going to go to 2 binomials. As an x and an x, I need factors of a negative 6 that will add to give me a negative 5. Yep, negative 6, positive 1. T-bar. Now at this point you should be really good at solving the factors, so I'm not going to write each one the long way by actually putting them equal to 0. I'm just going to solve and put the answer down. So x minus 6, if I was to solve that, I would get x as a positive 6 to make it equal 0, and x plus 1, that answer would be x as a negative 1. So now, the next step says to substitute a point between the roots into the original equality to determine the solution set. So, in order for me to find a point, I'm going to have to draw a number line. I'm going to place both roots on the number line. I'm going to go back up and look at my inequality symbol. It just says greater to, so it's only going to be open circles instead of closed circles. If it said greater than or equal to, I would have had to do closed circle. I'm going to test one number in between them to see if it works. So I'm actually going to use 0. So I'm actually checking 0. Is 0 going to work? I'll plug 0 into the original equality and get 0 squared is 0, minus 5 times 0 is 0. 0 minus 0 is 0, minus 6 is a negative 6. Is a negative 6 greater than 0? So hopefully you said no, it is not. So 0 didn't work. So my circles will not connect because 0 is between them. My circles will go in opposite directions. So when my circles don't connect, I need to write two separate inequality answers. So my first one is going to be, I need every value of x that's going to be less than negative 1. Or I need every value of x that's going to be greater than positive 6. And there's my answer. Okay, let's take a look at number 6 together. First things first, they said to write it as an equation. Okay, so I have x squared plus 4x equals a negative 3. Now I'm supposed to put it in standard form. So I'm going to add 3 to both sides and get x squared plus 4x plus 3 equals 0. I'm going to factor in t-bar. I can't GCF, so I'm going to go to two binomials. I'm going to set each factor, start them off with an x and an x. Factors of a positive 3, that'll give me a positive 4 plus 3 plus 1. T-bar. If I was to set x plus 3 equal to 0 and solve, I would get x as a negative 3. And if I was to do the same thing to x plus 1, set it equal to 0 and solve, I would get x equals a negative 1. All right, I'm going to place them on a number line. Negative 3 comes here. Negative 1 comes here. I'm going to check a number that falls between them, and the only one that I can check is a negative 2. So I'm doing a check for negative 2 to see if it works. So I'm going to plug it back into the original equality and see if I get a number that is less than or equal to negative 3. Okay, I want you to pause the video and try and check negative 2 into the original inequality and see what you get. Okay, did you end up with a negative 4 just like I did? If you didn't, double check, did you encase the negative 2 in a set of parentheses before you squared it? Because that makes a big difference. So you should have ended up with a negative 4, and a negative 4 is less than or equal to negative 3, so it does work. So taking a look at my symbol, I'm going to have closed circles, and since negative 2 worked, I'm going to connect the circles, which means I'm only going to write one answer instead of two separate answers. So how do you write an answer when your answer falls between your two values of x? Well, your answers are in the middle, so your x goes in the middle. Your number to the left goes to the left, and your number to the right goes to the right. And your values have to make sense according to how you read it. So you always read from the middle. So my x's have to be greater than or equal to negative 3, but less than or equal to negative 1. So another rule of thumb is when your circles do connect, your smaller number goes to the left, your larger number goes to the right, your x goes in their middle, and your inequality symbols always point to the left. Okay, so today we solved quadratic equations and inequalities. Tomorrow I'll answer any questions you may have about anything we did tonight, and we'll move on and solve some more in class together. See you soon.